Welcome students. So students, today we are going to understand about what exactly is an algorithm, a pseudocode and a trace table. So we're going to understand the difference between the algorithm and a pseudocode first, and the trace table is just an addition to that. So an algorithm is basically the logic or the step-by-step process to solve a problem. Okay, so we have a problem, we need to find a solution by writing a code. By writing a program, we have to find a solution. So what exactly will be the logic of that particular code? How you're going to achieve that particular, the task of solving the problem, right? What logic we are going to come up with? That is what algorithm is all about. So we always say, we need to come up with a better algorithm, or we need an algorithm for so and so thing. So normally we are talking about, an efficient algorithm that will solve the problem and in a much better way by, you know, less code and less execution time. So any program that takes much lesser execution time and less coding, so that particular algorithm will be called as an efficient algorithm. Then what is a pseudocode? A pseudocode, okay, is a way to represent an algorithm. So we want to represent an algorithm, so we will use a pseudocode. So pseudocode is basically a general way of representing an algorithm, and a pseudocode, is not associated with any particular programming languages. Now there are many programming languages like C, C++, Java, Python, you know, and many more. But pseudocode is not like, it will get associated with one particular programming language. It is just like a general way, a readable form of a program, of an algorithm, by which, we can share that information with others. So as a computer programmer, I write an algorithm and then I will share it with you, and then you can read that algorithm and you can understand what exactly I'm trying to code. Okay, so that's pseudocode. Now if you really go into the books and websites, so there are certain rules of writing pseudocode, but as such, as a computer programmer, I really don't think that there is any particular way or specific rule of writing a pseudocode, because pseudocode itself means like a general way or a readable form of an algorithm which is not associated with any programming languages. So we cannot have a particular rules and regulations. Okay, I'm going to explain you everything. I'm going to show you practically what exactly it means, and then we're going to understand about the trace table and what exactly it is. Basically a trace table is used to see whether our algorithm is working properly or not. Okay, whether we give a particular input and then whether it is giving us the output or not, so that the efficiency of, in a way you can say that to test whether we are getting the right output or not is what a trace table is all about. So these are the three things we are going to understand today. So let's begin without wasting any further time. So I will switch to Notepad, okay, and we are going to write a pseudocode for addition of two numbers. So how I'm going to write an addition of two numbers? Okay, so as I said, there is no particular rules to write a pseudocode, but it's just the way. Okay, I want to write an algorithm, okay, in form of a pseudocode and share it with you. So if there is a program like, the most simplest program, that is addition of two numbers, now I want to write a pseudocode for it. Basically I want to write an algorithm and I'm going to make use of the pseudocode. So how I'm going to do that? I can simply say, okay, maybe input a. This is the way of writing, right? I will say input a, so anybody reads, okay, input a means maybe user is going to give a value and that value is going to get assigned to a, right? Or I can say read value a, even that is fine. So it's not like you have to use input, okay, or you have to use read. Okay, both the messages, when I said input a or read value a, they kind of convey the same message. So it's okay, I can say that read value a and I say read value b. So that's perfect. So we are basically reading two values and we are storing those values in A and B. And now I have to add this number. So I can say add A and B and assign to C. And I can show how I'm going to do that, like C is equal to A plus B, right? I can do it this way. Even this is the way I can show it, or I can say add A and B and assign to C. Or if I even use this C is equal to A plus B. So any layman person who is not associated with programming or who is nothing to do with programming, even if he kind of reads these statements, he will kind of understand something out of it. All right, so if I say read value A, okay, reading a value A, reading a value B, and C is equal to A plus B, because everybody knows the basic mathematics, so he knows, everybody knows what is this equal to sign, plus sign, and everything, right? So if I say C is equal to A plus B, it means okay, A plus B is getting added and it is getting assigned to C. So it's okay if I write it this way, and then I can say print C. So it gives a very clear message, printing C, the value of C. So assuming the value of A is 2, B is 5, so we are going to have 7 out here, right? So it's pretty clear. So reading this, I can make it very clear, okay, this is an algorithm for adding of two numbers. So I can say print C, or I can say output C, and over here I can say input A, input input B. Even if I write this way, it's okay. Input A, input B, C is equal to A plus B, and output is C. So input, basically, that's what computer is basically, the three components that we have, that is input, process, output, IPO cycle, I mean to say. So the IPO cycle, when we talk about the IPO, that is input, process, output. So this is the program. You can say this is the input, this is the process, and this is the output, isn't it? So this is like more of a technical, but what I did before this was also okay. So reading value A, reading value B, C is equal to A plus B, and then printing the value C. It's completely okay. So this is a way of writing a pseudocode, and by which I am trying to represent my algorithm. Okay, this is going to be my algorithm. Okay. Now let us go and take up something more complex. Not really complex, but simple way, but a step further than what we did right now. And that is like, whether to check, to check whether a number is even or odd. Okay, so how I'm going to do that? I'm going to say input A or input N, and then I'm going to say that if N mod 2, if it is equal to 0, right? And now as a computer programmer, we know that mod means, okay, we are going to divide N by 2 and we're going to take the remainder part. Okay, so we can do it this way, absolutely not a problem. So if I share this with anybody, okay, the person is going to come to know, okay, this is mod means we are going to divide, and then I'm going to say, okay, if it is, then I'm going to say print, that is, okay, the number is even, right? Else I will say that the number is odd. Now this gives a very clear message. If I input a value that is N, so N can have any value, so user is going to give that value. And if I say if N mod 2 is equal to 0, now I'm not going to use double equal to sign as what we have, that's equal to, that's the arithmetic operator. But since this is just a pseudocode, I'm going to keep it as a single character, a single equal to sign. Okay, so if N mod 2 is equal to 0, print the number is even, else print the number is odd. So you can say N over here divided by 2, and then I can say check remainder is equal to 0, even that is okay. So you can write in a way where the person, if I share this with any other person, okay, so that person will get exactly what my algorithm is all about. So this is not associated with any programming language. So I'm not using any kind of syntax which is associated with any programming language, and that is all about pseudocode basically. Okay, and so pseudocode, we use it to represent an algorithm. So this is what we have as a pseudocode. Now let us take one step forward and you know okay, before I just move ahead, let us have a trace table for this particular algorithm. And the trace table can be of this form. So first I will write a trace table maybe for the addition of two numbers. Okay, so this is going to be my line number. Okay, and these are going to be my variables. So what change in the variables we are going to have if you know if I really execute that particular pseudocode line by line or the program. Okay, so for example, I have the same, I will write another pseudocode for addition of two numbers. So I will say input A and input B, and I will say C is equal to A plus B, and then I will say print C. Okay, so that's the addition of two numbers. Now let us write the trace table for this. So input A, so line, so this is going to be my line number 1, this is going to be my line number 2, 3 and 4. So we have 4 line of code, isn't it? That's the first line, the second line, the third line and the fourth line. So the first line is input A. So what I'm going to do is the line number 1, 2, 3 and 4. So we have 4 lines out here. So the first line, what is happening is I'm going to accept a value. Let me just change this to the capital A, capital B and C. Okay, so example, I will just assume maybe the value 2, and this I can keep it as empty. Okay, because these variables will not come in effect when we are in line number 1. Okay, so this is line number 1, that is input A. So I'm going to keep rest of these blocks as empty, and then I say line number 2, that is, what is that? That is input B, and let us assume the value of B, that is 5. Okay, so 5, this is going to be 2, and over here the value of B is going to be 5, and C I'm going to keep it as empty. Okay, so the at line number 1 we had the value of A as 2, B and C did not had any values. At line number 2, we had the value of A. Of course, we had the value of A as 2. It is going to be 2 itself. And the value of B now is 5. Okay, so that is the trace. What is every step, after every step, what changes are going to take place in the program or in the algorithm? It is what trace table is all about. And trace table basically helps us to find the logical errors and to check whether our algorithm is working perfectly or not. Okay, so at line number 2 I have a variable A that has the value 2 and variable B as 5. Now line number 3, if I go and check line number 3, I'm doing the processing part, that is C is equal to A plus B. So what I'm going to do over here is the variable A is going to be 2, this is going to be 5 and this is going to be 7. Fine, and at the last line this is going to be 2, this is going to be 5 and this is going to be 7, and we are actually printing the values. So we are not going to include that print values over here. It is just that we are concerned with the variables and what values the variables are going to have. Okay, that is what trace table is all about. So we are actually having the final value as 7, which is the right value. So this algorithm, I can say that this is working perfectly fine. Okay, this is a very simple one, right? So let us write another trace table for I'll just copy this and make another one over here, and so this was for addition of two numbers. Okay, and now this is for to check whether a number n is even or odd. Okay, now let us try to find this. So we are going to have only one variable out here, so I'm going to remove all this, that is delete cell. Let us see this. Okay, just a minute. So okay, I'll take a new table out here, or let me just divide this into 4. I'll split it into number of columns. I'm going to make it as 4, so I'll have the same thing. Okay, and now I'm going to delete this like this. Okay, okay, and this is going to be the line number and the value of n. So this is the line number. So 1 2 3, let me check the line numbers that we had, that is 1 2 3 4 and 5. So there are 5, but actually this is just a print statement, so it's okay. So we can show the output, not an issue. So 4 and 5, and this is going to be n. Okay, and how I'm going to show this now? Line number 1 is input n, so I'm going to take this as 23, and if you want, you can show the output in this way. Just a minute. Have this as 2. Okay, split everything into 2, that is let me just split this individually. No, not an issue. But trace table is more about about the values, how the values are getting changed. Okay, so I can show something like this output, and the value of n now is 23. That's the line number 1 over here, and then there is a check condition. So what I can do is bring it over here and split. Okay, let me see if it happens all together. Okay, so what I'm going to do is insert another column. That will be the best option. So insert and column to right. Okay, and remove this. I'm going to keep it out here, output, and over here this is going to be if that n mod 2. Okay, so what this if statement is going to produce is what we're going to check, and this I'm going to keep it as center, this as well. Okay, so if the number is 23, that's the line number 1, and then there is an if condition. So if condition n mod 2, and this condition is going to be false, right? Because the number is 23, and if we divide it by 2, we are going to have the remainder as 1 and not 0. So this is going to be false, and the output we have nothing. Okay, and at line number 2 we have the print statement. So this particular statement is going to get executed basically. So this is going to be as it is, this is going to be false, and output that we are going to have is this one. The number is even. I paste it and over here. Then at line number 4, that is an else part, so we are not going to have anything, and the output is going to be as it is. Okay, so it's not like multiple times we are having the output, we just that we are going to have the same value. Okay, then 23 and 1 2 3 4, so that's the else part. 1 2 3, just me 1 2 and 3. Okay, this is not going to be false because we are not checking any condition out here. We are going to keep this as empty. At the second line, that's false, And at the third line, okay, at the third line we have the print statement, so we're going to print, so that's fine. And at fourth it is the else part, so nothing is going to happen, so it is going to be as it is. And then at line number 5 it is going to be, this statement is not going to get executed, this is going to get skipped. So we are going to have the same output, that is copy this and paste it over here. Okay, so this is the trace table for the even and odd. And let me just a row above, and then I will merge this, center it, and then I will write the trace table for even or odd. Okay, and bring it out here. So this is the trace table to check whether the number is even or odd. So what the if statement is producing, what exactly output we are going to have. We are not much concerned with the printing statements, we are concerned with the variables and the and the if statements and the loops. Okay, so this is what it is all about. So, and this is a pseudocode that we had, and basically this is an algorithm, and I've represented this algorithm in form of a pseudocode. So we are going to have some more complex algorithms in the future, and we are going to develop the pseudocode for that algorithm. We are going to represent the algorithm through the pseudocode, and we are going to produce the trace table also. So this is for what we have today, and go ahead and prepare this table, trace table, and trace it line by line, and what exactly we are going to have the outputs and imports, please check it. Okay, so I will leave it this for today. So that's it for today, children. So again we'll meet tomorrow, and tomorrow we're going to take more about algorithms, pseudocodes, and we're going to have the trace table. Okay, so that's it for today. Bye for now.